In this question, this is the target equation NO plus not O2 negative NO2, and there is two equations one and two. Which equation one or two provide the NO reactant and product? I can see reactant and products in the target equation are found in question number two. Identify the intermediate species that must be cancelled. What is intermediate species? This is a species that's formed in one step and then cancelled in the other step. Doesn't show in the final equation. So I can see that O3 doesn't show. I cannot see this O3 here in the target equation, and I cannot see this O3 also in the target equation. So O3 is what needs to be cancelled. Which operation must be performed in equation 1 to align it for cancellation? In order to be able to cancel, this O3 and this O3 cannot be found on the same place, right? So I have to switch one of them. If you put O3 and O3 together, they will not cancel. So one of them has to be on the right and one on the left, which means that I need to reverse one of the two equations so that one of them will be on left, one of them will be on right on the target equation. But I cannot reverse this. Why you cannot reverse this? Because already NO and NO2 are in the right direction. They are already in the right. So I have to reverse the first one. So I have to reverse the first equation. Calculate the adjusted delta H for equation 1 after this operation. Oh, so I have to do for cancellation. If I cancelled only, see, this is O3 on the left and O3 on the right, but it is 2O3. So I have to reverse and then divide by 2. So I have to reverse and divide by 2. So what will be the delta H for this equation after I reverse and divide it by 2? Let's do on the calculator. Instead of 4, put 27 with the negative, it has to be with the positive, right? It has to be reversed, so it has to be negative, positive 427, and then divided by 2 is 213. Don't forget the sign is very important, 213.5 kilojoules. Now add all the reactants from the equation 2 and the manipulated equation 1 on the left. So let's add all the reactants from the equation 2. I will add all the reactants from the reaction 2, and the reactants here is actually here now, right? This is a new reactant. So let me write all the reactants. That's NO and O3. And this one I cannot write NO2O3. Not reactant, it will be the product. I will write this one. So that's 3O2. And then let's write all the products. I write all reactants and manipulate it on the left and all products on the right. So I will write the products. This is a product now. It's not reversed, and this is product after reverse. Don't forget that this one has to be divided by 2. You said that it will be reversed, right? So you go 3O2 divided by 2. And now you reverse the 2O3. It becomes here, and it's divided by 2, so it becomes O3. And then the other reactant is, the other product is NO2 and A. So this is product without reversing. This is product after reversing. Don't forget that I have to divide this full equation by 2. Even this one, I will divide it by 2. It will be delta H equal to plus 213.5 after reversing and division by 2. While this one, we didn't do anything in this equation. So it will be negative 122 kilojoules. This is the reactants, and here is the product. Now, after I did that, explain how 1.5 moles of O2, so 3 over 2, which means 1 mole and half mole of O2 is going to cancel out with half to form half mole. We leave half mole of oxygen because in the final I have half oxygen, right? And here I have 3 over 2 oxygen and I have 1 oxygen. So 1 mole of oxygen together with 1.5. This means that this one will cancel with this one. So what will remain? It will remain half mole only. That's what's happening. Actually, half mole of oxygen is remaining. Some enthalpy for the equation 2 and adjust enthalpy from step D. So let's put the plus 213.5 plus the 122 that's actually in negative. So we get plus 91.5 plus 91.5 kilojoules. Don't forget the sign. The final enthalpy changes to 3 significant figures, and based on the sign, the reaction will be endothermic reaction. It's going to be an endothermic reaction.